So in this video, we have two vectors, vector A and vector B, and we are given the magnitudes of each of those and the angle between them. And our goal is to first translate one of them. So our vectors go from head to tail, and then we're going to use some different law of sines, law of cosines, to find the magnitude of the sum of the two vectors. And so again, when we add two movements together, add two vectors together, we have to translate them head to tail. So even though this isn't going to be drawn to scale, I'm going to translate vector B so it goes follow the leader. Now from here, the resultant vector is from the starting point to the finishing point. And so usually we use vector R to denote that sum of this movement and this movement would overall get us from here to here. And so our goal is to find the magnitude of this vector R. Well, we're going to use some of the information that's given to us. And so I know that vector A's magnitude is 8 centimeters and vector B's magnitude is 24 centimeters. We started out by knowing that the angle theta in between them was 164 degrees, but now that we've had to move angle or vector B here, this angle is no longer relevant because it's not part of our triangle. So we're going to extend this path of vector A, and since these two lines are parallel, cut by a transversal, this angle will be equivalent to this angle right here. So that exterior angle will be 164 degrees, which would then mean that this interior angle is 16 degrees. So clearly not drawn to scale, but that's okay. So now the information that I know about my triangle is side, angle, side. So I'm going to use the law of cosines to find the magnitude of vector R. So we'll set that up. The magnitude of vector R squared is 8 squared plus 24 squared minus 2 times 8 times 24 times the cosine of the angle in between them across from the R, which is 16 degrees. Once you square, multiply, combine like terms, and then your last step will be to square root, we should get that vector R is approximately equal to 16.458, and that is in centimeters. Okay, so we answered the first part of the question. The second part of the question is going to be to find a direction, an angle. And so we're looking for the angle in degrees that the resultant vector makes with vector A. And so I'm going to use a different letter. I'm going to use the Greek symbol. Oops, let me change the color here. And I'm going to use the Greek symbol alpha. So that's the angle that I'm searching for. At this point, I know all three side lengths and I know an angle. So really I could use law of sines or cosines, and it doesn't matter which one you do here. However, there's potential for this angle to be obtuse. Remember that sine doesn't give us obtuse answers. So if you do the law of sines, there's a chance that it gives you the wrong answer. I'm going to go ahead and stick with the law of cosines for that reason. I'm looking for alpha. So I'm going to take vector A's magnitude, 8 squared, plus the resultant vector's magnitude that we just found. Keep in mind when you type this into your calculator, you may want to use the entire answer, not just the rounded. And I'm going to subtract the side length across from the angle that I'm looking for, so that'll be 24 squared. All divided by 2 times the 8 times the 16.458. Square, combine, multiply, divide. We're searching for an angle, so our last step would be to take the cosine inverse of whatever we get from this fraction, and we should be getting that angle to be 156.3003. And it did end up being obtuse, which makes sense since it's across from our largest side. So again, law of sines wouldn't have given this answer to us, it would have given us the reference angle. So we found both the direction and the magnitude of, the magnitude and the direction of the resultant vector, and so we're done.